Welcome to BSc Main Physics, Semester 6, Paper 1, Solid State Physics, Unit 2, Conduction in Metals. And today the class is about Fermi energy problems. Fermi energy problems, this is class number S29, Semester 6, BSc Main Physics, Paper 1, Solid State Physics. So before seeing the problem, let us have an idea about average energy of free electrons at 0K. Let us have an idea about average energy of free electrons at 0K. At 0K, absolute zero, electrons have energy. This energy is less than EF, the Fermi energy. Fermi energy. In that case, the Fermi-Dirac distribution function has a value that is F is equal to 1. You look here, average energy of free electron to 0K. At 0K, electrons have energy. This energy is less than Fermi energy EF. In that case, the Fermi-Dirac distribution function Fe has a value. Fe has a value, and that the value is 1. Fe is equal to 1. That is, Fermi-Dirac distribution function is 1. And this Fermi-Dirac distribution function is also called a probability, which is equal to Ni by Gi. Ni by Gi, this function is called Fermi-Dirac distribution function, or it is the probability. The average energy of electrons at 0K is written as the average energy of electrons at 0K is written as E0 bar. E0 bar is integral 0 to EF. Integral 0 to EF. ആ ഇൻ്റൽ മുമ്പ് ഒരു റൊട്ടേഷൻ ഉണ്ട്, അത് ആവശ്യമില്ല. ഇൻ്റൽ 0 to EF E dE into dE. And here this equation comes when Fe equal to 1. Fe, the Fermi-Dirac distribution function, we have taken as 1. So when we put that value, we get energy at 0K. Average energy of electron at 0K is given by integral 0 to EF E dE into dE, equation 1. Here dE represents number of states between energy range E and E plus dE. Here dE into dE represents the number of states between energy range E and E plus dE. Now, finding the value of 0 to E dE into dE. Finding the value of 0 to E dE into dE, and putting in equation 1, we get equation 1 മുകളിലുണ്ട്. അപ്പോൾ നമ്മളിവിടെ ഈ ഇൻ്റഗ്രൽ 0 to E dE into dE അതിൻ്റെ വാല്യൂ കണ്ടിട്ട് ആ മുകളിലത്തെ ഇക്വേഷൻ നമ്പർ 1 കൊടുക്കുകയാണെങ്കിൽ നമുക്ക് കിട്ടുന്നത് E0 bar is equal to 3 by 5 EF. E0 bar, that is mean energy of electrons at 0K. E0 bar is 3 by 5 EF. That is equation number 2. EF is called Fermi energy. അപ്പോൾ ഇലക്ട്രോണിൻ്റെ 0Kയിലുള്ള മീൻ എനർജി, ഇലക്ട്രോണിൻ്റെ 0Kയിലുള്ള ആവറേജ് എനർജി E0 bar, അതിൻ്റെ ഇക്വേഷൻ E0 bar equal to 3 by 5 EF. Question number 2. Now we can see some problems based on this. Some problems. Problem number 1. Calculate the mean energy and the speed of electrons at 0K. The Fermi energy is 8 eV. Calculate the mean energy. We start the Fermi energy problems. Calculate the mean energy and the speed of electron at 0K. The Fermi energy is 8 electron volt. electron volt. Answer. Mean energy or average energy is 0 bar is 3 by 5 EF at 0 K. Therefore, given EF is equal to 8 eV, therefore E0 bar 3 by 5 into 8, which is equal to 4.5 eV. So here, in this problem, the average energy or mean energy of electrons at 0 K is given by E0 bar is 3 by 5 into 8, which is equal to 4.8 eV. That is the answer. And also speed problem. In the above problem, we have to find the speed also, average speed also, speed of electron. And for that, we write the equation for kinetic energy. E0 bar is half m V0 square. That is V0 square is 2 E0 by m. V0 is equal to 2 E0 by m, the whole raised to half. M is the mass. M can be written as m star. M can be written as m star, where m star is the effective mass of electron in the metal. എമ്മിനെ നമ്മൾ എം സ്റ്റാർ എന്ന് പറയും. അത് ഇലക്ട്രോണിൻ്റെ മെറ്റലിനകത്തുള്ള എഫക്റ്റീവ് മാസാണ്. സാധാരണ കേസിൽ കോപ്പറിനൊക്കെ എം സ്റ്റാർ എം തന്നെയാണ്, റെസ്റ്റ് മാസ് ഓഫ് ഇലക്ട്രോൺ ആണ്. ആ വാല്യൂ ആണ് ഇവിടെ കൊടുക്കുന്നത്. ഹിയർ എം ഈസ് റെസ്റ്റ് മാസ് ഓഫ് ഇലക്ട്രോൺ. We can take in that manner. Therefore, V0 is 2 into 4.8 into 1.6 into 10 raised to minus 19 by 9.1 into 10 raised to minus 31, the whole raised to half. That is root. And we get V0 is equal to, on calculation, 1.3 into 10 raised to 6 meter per second. So the speed of electron at 0K, V0 is 1.3 into 10 raised to 6 meter per second. Next problem, Fermi temperature കണ്ടുപിടിക്കുന്ന problem. Calculate the Fermi temperature of valence electrons in silver given EF is 5.52 eV. Calculate the Fermi temperature of valence electrons in silver given EF is equal to 5.52 eV. You know the Fermi temperature TF is equal to EF by K, where EF is the Fermi energy and K is the Boltzmann's constant. The value of Boltzmann's constant is 1.38 into 10 raised to minus 23. So the answer will work out as TF is 5.52 into 1.6 into 10 raised to minus 19. This 1.6 into 10 raised to minus 19 is put in order to convert EV into joule. By K, K is Boltzmann's constant 1.38 into 10 raised to minus 23. We get 6.4 into 10 raised to 4K. That is the Fermi temperature. Next problem. This is an important problem. It is a CSIR problem also. CSIR problem. When we do some calculation, this problem. The density of silver is 10.5 gram per cc. Its atomic weight is 108. If each atom contributes 1 electron for conduction, find the number density of conduction electron to Fermi energy. So these are the values. You look here. The density of silver is 10.5 gram per cc. Its atomic weight is 108. If each atom contributes 1 electron for conduction, find the number density of conduction electrons and Fermi energy. അപ്പോൾ ഈ സിൽവറിൻ്റെ ഡെൻസിറ്റി 10.5 ഗ്രാം പെർ സിസിയാണ്. പ്രോബ്ലം ചെയ്യുമ്പോൾ അതിനെ നമ്മൾ കിലോഗ്രാം പെർ മീറ്റർ ക്യൂബ്ഡ് ആക്കണം. അറ്റോമിക് വെയിറ്റ് 108 ആണ്. ഓരോ സിൽവർ ആറ്റവും ഒരു ഫ്രീ ഇലക്ട്രോണെ കോൺട്രിബ്യൂട്ട് ചെയ്യും. എങ്കിൽ ഇലക്ട്രോൺ ഡെൻസിറ്റി കണ്ടുപിടിക്കണം, അതുപോലെ ഫെർമി എനർജിയും കണ്ടുപിടിക്കണം. അപ്പോൾ അതിന് നമ്മൾ നമ്പർ ഡെൻസിറ്റി, ഇലക്ട്രോൺ ഡെൻസിറ്റി കാണുന്നതിൻ്റെ ഫോർമുല നമ്മൾ നേരത്തെയുള്ള ക്ലാസ്സുകളിൽ പഠിച്ചതാണ്. ആദ്യം ഇവിടെ റിപ്പീറ്റ് ചെയ്യുകയാണ്. വി നോ ഇലക്ട്രോൺ ഡെൻസിറ്റി N is equal to small n is capital N rho by m, where N is Avogadro's number, rho is the density, and m is the molar mass. Rho is 10.5 gram per cc. On conversion into kilogram per meter cubed, we get 10.5 into 10 cubed. The multiplication factor is 10 cubed. And molar mass is 108 gram. Molar mass we express in gram first and then convert it into kilogram. 108 into 10 raised to minus 3 kg. Avogadro's number n is equal to 6.023 into 10 raised to 23. Avogadro's number n is equal to 6.023 into 10 raised to 23. Substituting the values, we get n rho by m. Put in that equation. N is 6.023 into 10 raised to 23 into 10.5 into 10 cubed by 108 into 10 raised to minus 3 is equal to 5.85 into 10 raised to 28 per meter cubed. Answer. That is electron density. And now we have to find Fermi energy. Fermi energy we have to calculate. Next is Fermi energy. And for that we use the equation Fermi energy EF is equal to h square by 2m into 3n by pi raised to 2 by 3. The power is 2 by 3, you understand. You have to do by a calculator. Fermi energy EF is equal to h square by 2m into 3n by pi raised to 2 by 3. That is EF is equal to 6.626 into 10 raised to minus 34 whole square, h square, by 2m, 2 into 9.1 into 10 raised to minus 31. Inside the bracket, the number density into 3 into 5.85 into 10 raised to 8 by pi, whole raised to 2 by 3. On calculation, we get 8.816 into 10 raised to minus 19 joule. Divide it by 1.6 into 10 raised to minus 19, then we get the answer in EV. So answer in EV is 5.51 electron volt. 5.51 electron volt. That is the answer. A similar problem is repeated for copper. The problem we have done is for silver, and now we do it for copper. Now the problem is for copper. You see the problem? The density of copper is 8.94 gram per cc. Its atomic weight is 63.5. If each atom contributes one free electron, find one number density of conduction electrons to Fermi energy. Same problem. In the place of silver, we write copper. Density will change and atomic weight will also change. Number density N is n rho by m. Number density, you know, it is n rho by m. And that we calculate. Avogadro number 6.023 into 10 raised to 23 into density of copper. That we say in kilogram per meter cubed by multiplying it by 10 raised to 3. So 6.023 into 10 raised to 23 into 8.94 into 10 raised to 3 by the atomic weight, which is molar mass, 63.5 into 10 raised to minus 3. We get 8.47 into 10 raised to 28 per meter cubed. That is compared to silver, electron has more electron density. You compare the two problems and see n, small n. This copper has more electron density. And Fermi energy EF is equal to h square by 8m into 3n by pi raised to 2 by 3. Put the values. Put the values, that is 6.626 into 10 raised to minus 34 whole square by 8 into into 9.1 into 10 raised to minus 31 inside the bracket 3 into 8.47 into 10 raised to 28 by pi 3.14 the whole raised to 2 by 3 joule. Here also you divide it by 1.6 into 10 raised to minus 19. You will get the answer 7.04 EV. Answer 7.04 EV is the answer. The answer is 7.04 EV. Now we pass on to next problem. Calculate the Fermi energy. Calculate the Fermi speed. The question is Fermi speed. Given that the Fermi energy of the given metal is 5 eV. The Fermi speed കാണാൻ പറഞ്ഞാൽ നമ്മൾ കൈനറ്റിക് എനർജി ഇക്വേഷൻ വെച്ചൊക്കെ ചെയ്താൽ മതി. ഈ ഫെർമി എനർജി ഈക്വൽ ടു കൈനറ്റിക് എനർജി എന്ന് വിചാരിച്ചൊക്കെ ചെയ്താൽ മതി. ദാറ്റ് ഇസ് EF is half mvf square. VF is Fermi speed. M star, we write M star. M star means M star is the mass of effective mass of electron in the metal. The Fermi energy we can write half M star VF square. VF is a Fermi speed. We find VF and then root VF is equal to VF square and then find root VF is 2EF by M star raised to half. And you remember in a conductor like copper M star is M, the rest mass of electron. So we write 2 in EF. EF is given 5 EV. 5 EV that we convert into joule by multiplying it by 1.6 into 10 raised to minus 19. Effective mass is mass of electron, rest mass of electron, rest mass of electron 9.1 into 10 raised to minus 31 and you note the power half. We get VF is 10 raised to 6 meter per second. Answer. Next problem. ഇത് 2019 പ്രോബ്ലമാണ്. അത് അല്പം കാൽക്കുലേഷനുള്ള പ്രോബ്ലമാണ്. അന്ന് ഈ പരീക്ഷയ്ക്ക് ആരെങ്കിലും ഇത് ചെയ്ത് കാണുമോ എന്നുള്ള സംശയമാണ്. അത്രയൊരു പ്രോബ്ലമാണ്. Fermi energy of a metal is 5 eV. Find the probability that electrons have energy 1% above Fermi energy at 300K. Fermi energy of a metal is 5 eV. Find the probability that electrons have energy 1% above the Fermi energy at 300K. ഇപ്പോൾ 300Kയിൽ ഒരു ഫെർമി എനർജി ഉണ്ട്. ഇവിടെ ഫെർമി എനർജി തന്നിരിക്കുന്ന 5 eV ആണ്. എങ്കിൽ അതിൻ്റെ പ്രോബിലിറ്റി എന്താണ്? ഈ 1% അധികം ഈ ഫെർമി എനർജി വരുന്നതിൻ്റെ പ്രോബിലിറ്റി എന്താണ് എന്നാണ് ചോദ്യം. അപ്പോൾ അത് ഈ ഫെർമി ഡിറാക് ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷൻ തന്നെയാണ് പ്രോബിലിറ്റി. ഫെർമി ഡിറാക് ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷൻ ഗിവ്സ് ദി പ്രോബബിലിറ്റി. അപ്പോൾ നമ്മൾ ആ എനർജി ഒന്ന് കണ്ടുപിടിക്കണം. ദി ഫെർമി ഡിറാക് ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷൻ F is equal 1 by e raised to e minus EF by kT plus 1. That you know. Fermi energy is EF is 5 eV. Energy above 1%. അത് വായിക്കേണ്ടത് അവിടെ ഒരു മൈനസ് കിടപ്പേണ്ട, അതിൽ ആവശ്യമില്ല. എനർജി above 1%. ആ മൈനസ് വേണ്ട. എനർജി above 1% of EF is equal 101% EF. That is 101 into EF. ഈ 101%നെ നമ്മൾ സംഖ്യയാക്കുമ്പോൾ നമ്പർ ആക്കുമ്പോൾ 1.01 എന്ന് വരും. Percentage can be converted into number by dividing it by 100. 1.01 into EF, that is 1.01 into EF is 5. 5, we get to 5.05 EV. അപ്പോൾ 5 EVയുടെ 1% കൂടിയാൽ അത് 5.05 EV ആകും എന്ന് മനസ്സിലാക്കുക. ആ വാല്യൂ നമ്മളിവിടെ കൊടുക്കുകയാണ് E minus EF കാണാൻ. Therefore, E minus EF is equal 5.05 minus 1 is equal to 0.05 EV converted to joule. 0.05 into 1.6 into 10 raised to minus 19. So we calculate the term in the probability relation. In the probability relation there is a term Fe. In the relation for Fe there is a term E minus E raised to E minus EF by kT. That we find here. The value of E, the base of natural logarithm is 2.718 raised to E minus EF 0.05 into, that is in joule, 1.6 into 10 raised to minus 19. E minus EF by kT, K is Boltzmann's constant 1.38 into 10 raised to minus 23 into temperature 300. That is in power of 2.718. And when we calculated that term in the power, we get 1.93. So that value is 2.718 into 718 raised to 1.93. And then we put the value in the probability equation, FE equation. F E equal to 1 by E raised to E minus F by KT plus 1. E raised to E minus F by KT is 2.718 raised to 1.93. That we put there, plus 1. And if we calculate 2.718 raised to 1.93 by a scientific calculator, we get 6.888 plus 1. So the probability F is equal to the Fermi Dirac distribution function. Actually, F is 1 by 7.888 equal to 0.1268. 0.1268. That is the probability. The probability is 0.1268. That is all with your 29th lecture on solid state physics. In the next class, we see the Fermi surface. That is all. Thank you very much.